In the diagram, rectangle ABCD is divided into 4 smaller rectangles by the lines PQ and RS intersect at X. The areas of these smaller rectangles are in some order 2, 6, 3a. What are the 3 possible values of a? Okay, so let's explore the ways that we can get the 3 possible values. And let's see here. So the first distribution I will do is 3. Well, I'll put 2 here, a here, 3 and 6. And then I gotta label this, so I'll just label it X, Y, whatever, W and Z. Okay, so then now the individual boxes, the areas are XZ is 2, YZ is A, WX is 3, and WY is 6. So that means that X is 2 over Z, and Y is A over Z. And therefore, if we take this guy, we can put, let's see here. We also have this guy. That would also give me that W is 3 over X. And then if I, yeah, I think that's pretty good. And then if I plug X here as 2 over Z, W becomes 3Z over 2. Okay, so then now I can use this guy to substitute. W is 3Z over 2, Y is A over Z, and that's 6. So the Z's cancel, and then I get A would be equal to 4, I believe. Okay, so I got one value. So that's sort of the way you do it. So let's try this again. So same kind of story, but this time a different allocation. This time I'll put A here, 2 here, 3 here, and 6 here, and sort of label it in the same way. Okay, so this time XZ is A, YZ is 2, XW is 3, and YZ is 6. Okay, so that means X is equal to A over Z, and then that means if we use this guy, X is A over Z times W is 3, so W would be 3Z over A. And then from that, hold on, let me see if I did this right. I think this should have been YW is 6, right? Yeah, YW is 6. You just got to make sure everything is right there. Okay, so then YZ is 2, so that means Y would be 2 over Z. So then now I can substitute into those guys. Y is 2 over Z, W is 3Z over A, and that equals 6. So that's going to be, the Z's cancel, so that's going to be, A is 1 if you crunch out those numbers. So there we go, we got another one. And then one last one, because they're saying we have to find 3 values for A. So a different allocation this time. 3 here, A here, 2 here, 6 here. Because here A was opposite 3, here A was opposite 6. So there's only one other number that could be opposite, and that's 2. So X, Y, Z, and W. So same thing. XZ this time is 3. YZ this time is A. XW is 2. And WY is 6. Okay, so that means X is 3 over Z. And therefore, if we sub it into that guy, that would be 3 over Z. W is 2. So W is 2Z over 3. W is 2Z over 3, and then from this one we get Y is equal to A over Z. And then now we can substitute both into there. W is 2Z over 3, Y is A over Z is 6, so the Z's cancel, and then we'll get 3 times 6 is 18, 18 divided by 2 is 9, so 9 is the answer for A there. So 4, 1, and 9 are the values for A, the 3 values. Suppose that the parabola y is equal to x squared minus 4tx plus 5t squared minus 6t has two different x-intercepts. Determine the value of t for which the distance between the two intercepts is as large as possible. So we've got some graph. I have no idea what it looks like, but I have a general understanding that it opens upwards. And if these two are the intercepts, so say this guy obviously and this guy, and we'll call it I'll just call this one x1 and this one x2. What we're looking for really is x2 minus x1, and we're trying to maximize that, so we'll just call it m, and then eventually we're trying to maximize m, right, as large as possible. Okay, so how do we do that? So I guess obviously first we'll start with the only equation they've given us, 5t squared minus 6t. And then the first thing I want to do, what is the first thing I want to do here? Probably get the x-intercepts, and then I'll work from there. So to get the x-intercepts, I have to set y to 0. I can't think of any other thing to do. So I'm going to break this up into a slightly different way, and you'll understand why. I did this because I wanted it to resemble ax squared plus bx plus c. And therefore, I can easily illustrate what is a, b, and c. A is 1, b is minus 4t, and c is 5t squared minus 6t. And some of you don't need me to do that, but some of you may need to understand when I'm going to do the quadratic, right? Minus b plus or minus the square root of b squared minus 4ac. Yeah. Okay, so this thing becomes 4, oh, forgot all over 2a. Don't forget that. So this is going to become 4t plus or minus, oh boy, so what's that, 16t squared, and then minus 20t squared plus 24t, I think, and all over 2, don't forget that. So 4t plus or minus, so this will be 24t minus 4t squared. And then 4t, so I guess you can factor out a 4. And when you kick it out of the radical sign, it'll be a 2. And then what's left under the radical would be 6t minus t squared, I believe. Yeah, and then that's all over 2. So then that will be 2t plus or minus 6t minus t squared. Okay, so that means that we've got our two values for x, x1 and x2. x1 obviously is the larger one, so that's going to be the 2t plus the 6t minus t squared. And x1 obviously is the other one, so that would be the 2t minus 6t minus t squared. Okay, so now we can then concentrate on the distance, which is right here. So x2 minus x1 would be 2t plus 6t minus t squared minus 2t plus 6t minus t squared when you subtract them. And the 2t's disappear, so all you're left with is this two of these radical signs. Okay, so we are trying to maximize this, because this is m. We are trying to maximize that. Okay, so that's what after all that big long song and dance, that is what the question has come down to. Now this is going to be very difficult to maximize, so what I'm going to do is I'm just going to square it. And if I square it, then the radical disappears, and that becomes much easier to work with. So I'm trying to maximize this. So that means if I expand this out, it's minus 4t squared plus 24t. Okay, so that is some sort of a parabola. And because it begins with a minus 4, it's pointing downward. Now, I have no idea what it looks like, but I just know that it's downward. So this would be the maximum point right here. So this point right here is going to have some x value and some y value. So that is how we'd figure this out. But how do I figure that out? Well, actually, I labeled it incorrectly. It should have been t and m squared, I guess. But, I mean, it doesn't really matter. I just wanted to illustrate that. So how do we figure out that point right there? Well, there's a few ways, but the quickest way, I think, is just to complete the square. complete the square. So let's go. Minus 4, factor that out. And then when you divide minus 4 at 24, that'd be minus 6, right? Yeah. Okay, so then take that coefficient, which is minus 6, take half of it, which is minus 3, and then square it, so 9. And that's what you'd have to add and subtract to complete the square. So minus 6t plus 9 minus 9. So then now these three terms factor beautifully into t minus 3. And then you got to kick out that last term, but don't forget to multiply it by that negative 4. So it'd be plus 36. So that basically means that this is 3, and that's 36. That when t is 3, that whole thing vanishes, and we get m squared equal to 36. But we are not interested in m squared, we're interested in m. Remember, that is what we're trying to maximize. So m, therefore, is 6. And that is the answer to the question. There are m integers between 10,000 and 100,000 that are multiples of 21 and whose units digit is 1. What is the value of m? So we have integers that are multiples of 21. So let's just say they're 21 times something. I just put k. You can put any letter you want. And they're between these two numbers, 10,000 and 100,000. So let's just divide through by 21 and let's see what we get. We get approximately 476 on this side and 4761 on this side. So that means every multiple of 21 in where k is between 476 and 4761 would initially qualify just for that first criteria that they're multiples of 21. But then we eventually have to look at that second criteria, which is that they have a units digit of 1. But let's just look at the first criteria first. So let's see here. Let's start off with 475 times 21. Let's just see what that number is. It's 9975. Okay, so that doesn't qualify because we've got to be greater than 10,000. But let's try 476 times 21. And that's, oh, that doesn't qualify either. That's 9996, okay? But this one would, 477 times 21, because that is 10017. Okay, so now we got our first one. And then let's just keep going here. Let's write out a few of them, because I think, or at least I hope, there's some sort of pattern here that will allow us to see how many I need to actually get. 59, and 480. I'll keep writing them until I see a pattern. So far I don't see anything. 481. Maybe some of you do, but I don't. 101, 01, 482. Yeah, let's see. I basically imagine just adding 21 every time. So 101, 22, right? Yeah. And then 483 times 21 is 10143. And then 484 times 21 is 10164. And then 485 times 21 is 10185. 486 times 21. Oh boy. 10206. Okay, I see a pattern. Okay. And the pattern is 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. So the units digit that increases by 1 every time. Okay, that's a pretty decent pattern. And then dot, dot, dot. You guys get it. And then eventually I want to get to the absolute end boundary. Well, 4761 times 21, what's that? That is 4761 times 21, 99981. Okay, so we're still within the boundary. And I think the very next one will go out of it. Yeah, 10. Obviously, just add 21, so it'll be 002. Okay, so basically, we started here, 477 times 21, and we ended here. Interesting. I think this was 0.9. That's why I was wondering if it's less than 4761, then how come 4761 qualifies? Because I forgot the decimal. Okay, no problem, as long as I catch it. And this was 0.2 just for the sake of completion. Okay, so now after all that, we satisfied the first criteria, but we still got to worry about this one. The units digit has to be 1. So far, this is the only one that qualifies right here. So we have to look at some sort of pattern. Well, we got the pattern that the units digit just increases by 1 every time. So what that means is that the first one, just make a list here, was 481 times 21. That is the first one that qualifies in our list. So the next one, since every 10 it would go back to 1, and you can keep doing this if you want to keep extrapolating this, but you don't have to write it out manually. You can just jump. It would be 491 times 21 would be the next one. And if you do that, that's 10211. And the next one would be another 10, so that'd be 501 times 21. So that doing this actually helped a great deal. It helps us identify the pattern. So 105, I think that, sorry, 103, 105, 21. Yeah. Okay, and then so on, all the way up till the last one would actually be, it's right here, 4761 times 21, and that's 99981. So these are the ones that they want. And that shouldn't be that difficult to figure out how many. I actually think you can do it just by looking at these guys all the way till here, because it's every 10th. It's not every single one. It's every 10th. So the grand total would be 476 minus 47, actually, because this one would be 471, the one that immediately was before it, like 10 before it. So that is the total. And 476 minus 47 is 429. So 429 is the value for M, which is what they have asked for. There are N students who attend Strickland Secondary School, where N is between 500 and 600. Among these N students, 2 over 5 are in the physics club and 1 over 4 in the math club. In the physics club, there are 2 times as many students who are not in the math club as there are students who are in the math club. Determine the number of students who are not in either club. So we have to use what is known as a Venn diagram, and those are not that difficult. I'll explain it. So we draw 2 circles, and of course they're going to overlap, and then they're going to be in a box. So let me explain. So the first circle represents the physics club. Second circle represents the math club, and I will have to label them. So this section I'll call A, this I'll call B, and then in the middle C, and then the ones that are not in either club, sort of outside of those circles, will be D. So the total number of students is all of those letters, A plus B plus C plus D, and that's N according to that. And they've told me that N is somewhere between 500 and 600. So now let's look at the question. What are they saying? They're saying that 2/5 are in the physics club. So the physics club in this Venn diagram are denoted by A and C, and that's 2/5 of N. So A plus C is 2/5 from N. And 1/4 are in the math club, and the math club is B plus C. Those are the 2 sections that make up the full math club, the full circle, and that's 1/4 of N. Okay. And then we are told this sentence that there are 2 times as many students who are not in the math club as those who are in the math club. So let's think about that. How many, first of all, are in the physics club? Okay. So if you're looking at the physics club, that's A plus C. And they're saying in that physics club, there are 2 times as many students who are not in the math club. So the ones not in the math club are denoted as A, correct? And the ones that are in the math club are denoted as C, because C is part of that math club circle, literally. So they're saying that A is twice that of C. So A is 2C. And that is the interpretation of that sentence. And then what are they saying? Determine the number of students who are not in either club. So then eventually we have to find D. So this is the setup of this question. So that's all I've done so far, just set it up. So now let's try to solve it using whatever equations we have. Oh, let's see here. let's start with a plus c. That is 2/5 of n. Correct? And then I can use that. So let's see here. We got a is 2c, so 2c plus c is 2/5 of n. So that means 3c is 2/5 of n. And that means that c looks to me like it's 2/15 of n. And then therefore a would be 4/15 of n, if I did that correctly. I think I did. Okay, so then since we got a and c in terms of n, let's try to get b in terms of something, in terms of n. So b plus c is 1/4 n. Well, I think I can just substitute c, right? So since c is 2/15 n, then I can just do that. And then when I solve for b, get a common denominator and all that, it'll be 7n/60. Okay, so that's pretty good progress. So then what's next now? Now I guess we'll just go to the big equation, since we only have one letter left that's not in terms of n yet, d. So since n is equal to a plus b plus c plus d, right? So n would be, well, a is this guy, so that's 4/15n. b is this guy, 7n/60. And c is this guy, 2/15n plus d. Okay. All right. And then when we crunch out all those numbers, we get n is equal to 31n/60 plus d. And then finally, when you solve for d, you'll get 29n/60. Okay. So that's great. That worked out very nicely. The Venn diagram helped very much. So then what are we trying to figure out? For the actual numerical value of d. Okay, so that's where that inequality would come in. So we know that n is between 600 and 500. Okay, so since d is what we're trying to figure out, let me plug in that one. So multiply everything by 29/60. So 29/60 here. 29/60 here, and 29/60 here. So then therefore that just basically is d, and then we need to look at those numbers. But this question at this point is a bit tricky, because when you figure out those numbers, it becomes 241.6 and then 290. And I think, well, then what's d? D has a whole bunch of values, right? But the key is not to do that. The key is to look at this right here and understand that since we're always talking about integers, n must be divisible. Divisible by what? Divisible by 60 in order for d to, in order to get d. So that is the key. And since n is between 500 and 600, the multiples of 60, well, 60, 120, and so on, right? So 480, and then 540, and then 600. So the only multiple of 60 in that range would be 540. So n is 540. And if n is 540, then we can easily figure out d. D would be 29/60 times 540. And that calculates to 261. 29/60. I think I might have said 40 for some reason, or whatever I said. Well, at least I wrote it correctly. 29/60 times 540, and that gives you 261 for D, and that is representing the number of students who are not in either club. Arun and Bella run around a circular track starting from diametrically opposite points. Arun runs clockwise around the track and Bella runs counterclockwise. Arun and Bella run at a constant but different speeds. They meet for the first time after Arun has run 100 meters. They meet for the second time after Bella runs 150 meters past their first meeting point. What is the length of the track? All right, so let's draw this diagram here. And let's see. This is the center. Let's put Arun at the top. So Arun goes here, right here. And diametrically opposite, so exactly opposite on the other side. So right here is where we'll put Bella. Okay, So throughout this, we're going to use those standard formulas. Speed is equal to distance over time, or any other formula that you can get from that first one. Time is equal to distance over speed, and distance is equal to time times speed, and so on, right? So those are the standard formulas throughout this question, throughout any question of this kind. Okay, so now let's talk about this. We have the first scenario. They're saying that they meet when Arun has run 100. So he's going this way. So let's just say that's 100 meters. So that distance is 100, and we'll call it M1 for the first meeting 1. Now, Bella's running that way, and the distance from hers to M1, I don't know. But what I do know is that since they're diametrically opposite, that half would be the circumference of the circle divided by 2. And then she is going, therefore, circumference of the circle divided by 2 minus that 100. Got it? Because if you add it to the 100 that Arun traveled, it would be half of the circle. So that is, I'm pretty confident that's the first way of setting it up. Okay, now the next way of setting it up with the second part is the same kind of circle, but this time it's a little bit different. They meet for a second time when Bella runs 150 meters past their meeting point. Okay, so she started here, she ended up here at M1, and then 150 meters more. So since that was 100, she's going in this direction, she's going to end up here, where this is 50. And this is the M2, right there. That's M2. And then, so Bella went from here to here, and that was C2 over minus 100. Okay, and then, what's his name? Arun, he basically was here, M1, and then he goes all the way till M2. So that means he traveled C minus 150, is that right? The whole way around. Let's discuss this. Let's backtrack here and let's talk about this. The distance traveled by Arun, so dA in the first part is 100. That's pretty straightforward. And the distance traveled by Bella in the first part, that's C over 2 minus 100. Okay, so that I know for sure is correct. C over 2 minus 100 and 100. Okay, now the second part, that one we need to think about a little bit. The second part, the distance traveled by Arun and Bella. Well, Bella is going from here to M2, right? So she went initially C over 2 minus 100 to M1, and then she travels another 150. So according to the question. So that's C over 2 plus 50. So that's dB, the distance of Bella in the second part of the question. C over 2 over 50. C over 2 plus 50, sorry. And then Arun, he initially did 100, and then he started here, right? This is where he starts. And then he ends up, he goes clockwise all the way till M2. So that means he's gone the entire circle except that 50 meters. So he would basically be C minus 50. Yeah. Okay, I'm confident that is right, so that we can progress with. Okay, so here we go. Okay, so then we're going to need two sets of equations. So for the first one, that would be, which one you want to use here? The times are equal when they meet, so that we're going to have to use that equation. So the times are equal, so the time for Arun is going to be the same as the time for Bella. So that's going to be dA over SA, and that's going to be dB over SB. Well, dA is 100 over SA. dB is C over 2 minus 100 over SB. And therefore, let's just get an equation of SA over SB. SA over SB would be 100 over c over 2 over minus 100. Yeah, and then if we multiply top and bottom by 2, I'll get 200 over c minus 200 is SA over SB. Okay, so that's a pretty good finding, I think. 200 over c minus 200. Okay, so then the same story over here. The times are equal when they meet for the second time. So that's, again, dA over SA is dB over SB. And then bring it up over here. So dA this time is the c minus 50. And the SA, I don't know. And then the dB this time is c over 2 plus 50. And the SB. So again, I'll get the SA over SB situation. That's c minus 50 over c over 2 plus 50. Multiply top and bottom by 2 to get 2c minus 100 over c plus 100 is SA over SB. There we go. So now we got two equations that have the same thing, and we can set them equal to each other. This guy and this guy are the same. So that means that 200 over c minus 200 is equivalent to 2c minus 100 over c plus 100. Okay, great. All right, so cross multiply. So you'll get 200c plus 200 times 100, and then cross multiply this guy with this guy, and you will get 2c squared minus 400c minus 100c plus 200 times 100. Put everything on one side. Well, this cancels with that, and then that would be 0 is equal to 2c squared minus 500 minus 200 minus 700c. Divide through by c, and we get 2c minus 700, and therefore c is 350. And that is what we had to figure out, that the length of the track. And the length of the track is the circumference, and it's 350. Determine all angles theta, which theta is between 0 and 360 inclusive, for which 4 to the power of 1 plus cos theta cubed is equal to 2 to the power of 2 minus cos theta times 8 to the power of cos theta squared. I'm going to change all of those to powers of 2. So cos theta cubed, and then that's already as a power of 2. And that's 2 to the power of 3 times cos theta squared. Okay, so then if we use the exponent laws, that's going to be 2 plus 2 cos cubed theta. That's going to be 2 minus cos theta. And that's 3 cos theta squared. So 2 plus 2 cos theta cubed is equal to, and then we add these exponent laws, so that's just going to be 2 minus cos theta plus 3 cos squared theta. Correct? Okay. Well, the bases are the same, so the exponents must be the same. So that means 2 plus 2 cos theta cubed is the equivalent of 2 minus cos theta plus 3 cos theta squared. Okay, so let's put everything on one side. So this will be 2 cos theta cubed minus 3 cos theta squared plus cos theta, and I think the 2's just cancel, so there we go. Okay, now we can factor this, so let's factor out a cos theta, and then we get 2 cos squared theta minus 3 cos theta plus 1. And I think that also factors what's in the brackets very nicely. 2 cos theta, 1, 1, negative, negative. Great. So that means cos theta is either 0, cos theta is either 1, or cos theta is either 1/2. And keep in mind, we had a range, 0 to 360. So you guys remember the graph of cos theta, right? So let's see if I remember. It starts here and it goes down like that, there. And then we're just interested from 0 to 360. So if this is theta, and that's cos theta, this is 0, and this point right here, 360 right there. Okay, so this was 0, this I believe was 90, this point is 180, this here is 270, like that. Okay, so when cos theta is 0, that means that theta is 90 or 270. Yeah, so that means theta is 90 or 270. When cos theta is 1, so this is 1 right here, and this is -1, the upper and lower boundaries. When cos theta is 1, that means theta is 0 or 360. Yeah, 0 or 360. And then a half, well, half would be here, so that would be here and here, and I know those. You know, I've done this so many times, but even if you don't, you can use your calculator. 60 degrees, and the other one would be 30 degrees plus 270, so that would be 300. So 90, 270, 0, 360, 60, and 300 are the values of theta that satisfy that equation.